HVAC is one of the most important systems in a building. Why is that so? Its primary objective is to create a comfortable environment for occupants, especially thermal comfort. When we talk about thermal comfort, temperature and humidity always come to our mind, but it is more than that. It also includes the airflow rate, the noise level of air coming out from the diffuser, and the air quality such as carbon dioxide or oxygen level. All these are taken care by the HVAC air distribution system. This is the water-cooled chilled water system, which is one of the most common cooling systems in a building. The HVAC can be categorized into the water side and the air side. Most of the equipment you see over here, such as the chiller, cooling tower, pumps, they belong to the water side equipment. The only air side equipment over here is the AHU or air handling unit. This is the place where heat transfer between cold water and warm air takes place. This simplified schematic shows all the different loops happening in the whole HVAC system. This is the condenser water loop, and this is the cooling tower, this is the condenser water pump, and the next loop over here is the refrigerant loop, which is happening inside a chiller. The four symbols over here are namely the compressor, condenser, evaporator, and expansion valve, and they are the main components in a vapor compression cycle. Next, we have the chilled water loop. You have the chilled water pump over here, circulating the chilled water around to different cooling coils in the building. Lastly, the yellow loop is the air loop, which represents the air distribution system. So in this course, I will cover extensively on this particular loop, which is the air side of HVAC system. And by the way, the purple lines are representing the control loops. That is why it is linked to the thermostat, valves, and fan, as these are the inputs and outputs to maintain the space at certain temperature or condition. It is also sending information to a computer, which houses the building management system, or usually we call it BMS. In this course, I will start off with the calculation of space cooling load, identifying different internal and external heat gain into a space, as that is the starting point or motivation behind the equipment selection downstream. Only when we know the cooling load, then it's possible to size the equipment such as a supply air fan and the cooling coil to ensure that they can deliver adequate cooling to the space. The transportation of air is through air duct, and this is critical too. So you will learn how to determine the correct duct size for different requirement and application. If we take a closer look inside an air handling unit, these are the components that you will see. This is the fan, which is the main driver that delivers the air to the room through the air duct. And in front of the fan are cooling coils. In this particular AHU, there is a heating coil too, which means that this AHU can provide warm air in cold countries or in winter. All the coils are there to provide reheat to reduce humidity. And right in front is the air filter, which helps to clean the air before circulating it back to the space. Along the air distribution network, there are various components too, other than the air duct itself. There are dampers that help to modulate the amount of air flowing through it, such as this, which is called volume control damper, that is part of the variable air volume terminal unit. The position of the damper depends on the temperature in the room, and the interaction between them is controlled by the BMS, which I will cover in this course too. Finally, the air will reach its endpoint through the air diffusers, which are the only components that occupants can see. To summarize, the air side components consist of the supply air fan, the air filter, and the cooling coil. These three components are inside an AHU or FCU. And we also have the air duct, such as supply air duct, return air duct, and fresh air duct. Along the duct, there are dampers, such as fire dampers, volume control dampers, and air diffusers. So all these will be discussed systematically in the subsequent videos.